Welcome back to another episode of Stoked About Science. Think about the last time you went swimming. Did you notice that the deeper you went in the pool, that your ears hurt more? That's because there's more water above you, and the weight of all that water creates more pressure pushing down on you. We can see that here with this water bottle that I have. I drilled holes in it, and I filled it up with water and blue food coloring. Then I covered them with tape. And when I pull off the tape, you can see that water squirts out because of the pressure inside. Notice that the pressure at the very bottom is the highest, so the water squirts out the farthest. And that's because that hole has the most water above it pushing down on it. We actually live at the bottom of a really big swimming pool, an ocean, but it's filled with air, not with water. And the deeper you are in that, the more pressure there is on you. So for those who live at the coast, you have the most pressure on you because you're at the very bottom. For those who live like in the Boise area here, not quite as deep, there's less pressure. If you're at the coast, it's about 14.5 pounds per square inch. If you're here in the Boise area, it's more like 13.5 psi. As you go higher and higher up in the mountains, then you have less and less pressure because you're not as deep in the ocean of air. For my daughter's science project, she decided to measure pressure, so we drove up to our local ski resort, Bogus Basin, and used a pressure sensor to measure the pressure as we increased our elevation. We also took video of it as we went, so here it is. Check it out. When my daughter graphed today, she got a pretty straight line. She used millibars for the pressure rather than psi. There's lots of units that you could use. But she found out that for every 1,000 feet, the pressure drops about 31.6 millibars. And that if you were at sea level, or 0 feet, it would be about 1,019.5 millibars or so. And that's pretty close to what it really is. You can see from this graph from Wikipedia that the pressure actually curves as it decreases, but this is from going from sea level to about Mount Everest kind of height. We were only looking at something a little bit less than 1,000 meters to a little bit over 2,000 meters, and in that small section it seems to be fairly straight. I'll end with this cool demo. I've got this rubber mat here, and right now there's 1,000 pounds pushing down on it, but if I squish all the air out underneath it, between it and the stool top, it can lift up the stool top. Break the seal, and air rushes in and balances it out. I can do the same thing on this desk. Squish all the air out, and there's 1,000 pounds pushing down and nothing pushing up on the bottom of the mat, and so it lifts up. As soon as I break the seal, though, and let air in, boom, it can't lift anything up. Pressure differences can really make some huge forces. Thanks for watching.